Can you hear my voice? Hello, everyone. Can you hear? Can you hear or not? What's happening here? Not sure what happened. Yeah. Can you hear the voice now? Can you hear? Yeah, can. All right. Okay, that's good. Yeah. Hello, everyone. Okay. Nice to meet you all. Now let's look at our slides. Yeah. Okay. Now I shall teach physical optics. Yeah. Okay. Can I start now? Okay. I don't want to waste your time anymore. Okay. Sorry for the delay. I'm actually using a lot of effort to prepare these notes, and I just finished prepare the notes, and now I present to you all. Okay. So hope that all of you appreciate the knowledge that you gain today. All right. First of all, physical optics. Yeah. What is actually physical optics? Physical optics actually talks about, because you before in this previous lesson you already learned about geometrical optics. Yeah, you already learned about geometrical optics. Okay, let us go a little bit recall what we have learned in geometrical optics. In geometrical optics, you are learning about two characteristics of light. Two characteristics of light as wave. Yeah. What is wave? Wave is propagation of energy, we can say. Yeah. So you learn geometrical optics. You learn two characteristics of light behave as wave, which is the reflection, okay, or refraction. Refraction. These are the characteristics. The characteristics of wave. Only wave can behave like this, like reflection. Only wave can be reflected and refracted. These are wave properties. Yeah, we can say these are wave properties. Okay. Now, today, physical optics is also called as wave optics. In other syllabus, they call it wave optics. These, you learn another two characteristics of light as wave. Light as wave. So, which are the two other characteristics? The number three, which is the interference. Interference of light and diffraction. So these reflection, refraction, interference, and diffraction, these four are wave properties. We say these are wave properties. Only wave can behave like this. Only wave can be reflected, refracted, interference, and diffraction. The particle cannot behave like that. Particle cannot behave like this. Yeah, all these are wave properties. Yeah, all these are wave properties. Understand? Okay, it's very important because in later chapter you're going to learn things between wave and particle. Okay, so this chapter is actually a continuation from the chapter before. Okay, last time you learned about reflection and refraction. Now we continue with the another two properties, which is interference and diffraction, right? In physical optics. Now, I start off with Huygens principle. What is actually Huygens principle? Huygens principle explains about this diffraction. Yeah, diffraction. Now he says that every point on the wavefront can be considered as a source of secondary wavelets. Okay, secondary wavelets that spread out in the forward direction at the speed of the wave. The new wavefront is the envelope of all the secondary wavelet, which is tangent to them all. Okay, let me highlight. Every point on the wavefront is constantly. Every point is a source of secondary wavelet. Source of secondary wavelet that spread out in the direction of the wave, direction of the wave, and then it form a new wavefront, which is the envelope, which is the envelope of all the wavelet, of all the secondary wavelet, which is tangent to them all. What I can say is, you see, this is the first wavefront. You see, this AB, this is a source. This is a source. How the wave can be propagated out? How can the wave can be propagated out? You see, this source produce the first wavefront. We can say this is the first wave front. You understand? This whole thing AB. AB is the first wavefront. AB is the first wavefront. Now he said, every point on the first wavefront, every point on the first wavefront, that means every point of this, every point on the wavefront of AB is another source. Another source for secondary wavelet. What is a wavelet? Do you see there is a very small wave, which generated out of each point of the first wavefront? These are called secondary wavelet. These are called wavelet, small wavelet, small wavelet. These are like this. The first point, it produced one wavelet. The second point also produced one wavelet. The third point also produced another wavelet. This point also produced another wavelet. So all points produce their own wavelet. You see that? It's a source of secondary wavelet that spread out in the direction of the speed of the wave. The speed of the wave is this one. We call it ray. You see, this is the ray, means the direction of the wave. Ray means the direction of the wave. You see, this is the direction of the wave. You see, direction of the wave. All come from the source, isn't it? So it produced the wave in the direction of the wave. We call it the ray. Now, you see this small wavelet, then it form another wavefront. We call a new wavefront, which is the second wavefront. Which is a second wavefront. Just now it's the first wavefront. Now it's a second wavefront. It's the envelope of all the secondary wavelet. Envelope, that means cover all the secondary wavelets. So all these small wavelet, they form another wavefront. So this, you see, which is the tangent of them all. Tangent means just touching the wavelet, touching. So this is, you see, it form another wave, a big wave here. This is what we call second wave front. So the big one is called the wavefront. The small one is called wavelet. That's it. So this is how the wave is spreading out, or we can say diffracted out. Diffract. This is what we call diffraction. This is what we call diffraction. Diffract out. Out of, or we can say spread out. Spread out. The energy spread out. This is how the energy spread out. This is what it means by Huygens principle. So this is only one source. What if it is the plane? How to produce plane wave, spherical wave, single slit obstacle? These are the things, the examples. Like maybe question will ask you how to draw. Draw the new wavefront. How do you draw? Let's say I start off with just a line. So every point produce their own wavelet, and then I just draw another tangent to cover all the wavelet. So it become a new wavefront. See? And then this one is actually the same as this one. What if a single slit? The wave come here, and then you see every point on this produce a wavelet. So the center, the middle is still a straight line, but the side is following the shape of the wavelet, following the shape of the small wavelet. So it's a curve lah. So at the side is a curve. You see that? It's a curve. And then this one produce another wavefront, another wavelet. So the wavelet also curve. That's why diffract. At the side here, you see at the side over here, I should use a red color one. Okay, you see over here is that is this what you diffract. Yeah, diffract. Diffraction happens here. Yeah, at the side there. Okay. This one also the same. You see, at the side here, here is what we call the diffraction lah. Diffraction happens. Yeah. Okay, so you must learn how to draw this. Yeah, you must learn how to draw this. Now let's go on to the next slide. Next slide. Okay. Now I want to talk about interference. Yeah, I want to talk about interference. You learned this before already. What is a constructive and what is destructive interference? You learned before. Constructive means they reinforce each other. Destructive means they total cancel each other. Yeah, I will go one by one. First of all, stable interference pattern. Or what is meant by interference pattern? Actually, this is the thing happen for wave. If let's say, imagine you have two slits. You have two slits. So when you shine a wave on it, yeah, when you have a wave coming, yeah, wave is coming. It will not just form two dots over here. You understand? It will just, because it's not particle. Particle it form two dots, but this is a wave. This is a wave. You understand? This is a wave. It don't just form two dots because of two slits over here. It don't just form two dots. What it form actually is a array of interference pattern. We say that interference pattern. That means it got a bright fringe, dark, and then bright. Okay, so first of all, I should use a black color, easier. Yeah. So in the middle, it produce a bright fringe, and then produce dark fringe, and then bright, dark, dark fringe, and so on. Yeah. Instead of forming just two dots, instead of just forming two dots, it form array of bright, dark. Yeah. It form array of we call it. This is what you call interference pattern. This is what we call interference pattern. So to form these interference patterns, it is by principle of superposition of wave. Superposition, you need two waves actually. Yeah, you need two sources of wave. How to form this pattern is by superposition. That means overlapping of these two waves. You have wave 1 and wave 2 overlap with each other, and then they form this interference pattern. I will talk more deeper into this. Yeah, I will talk deeper into this. Later I will show you how can it form a bright fringe, dark fringe, and patterns of interference pattern of this. Yeah. So this interference pattern is formed by principle of superposition. Superposition in other words, is called overlapping. So what's the condition? This normally objective to ask you. What's the condition to produce this pattern, interference pattern, a stable one? Stable means this interference don't change. Yeah, it is stable. It don't just change over time. This is called stable. How to form a stable interference pattern? First, you must have two coherent source. What is meant by coherent? These are the thing. Yeah, these are the coherence means by coherent source. Okay, first of all, you need two sources. Okay, you need two coherent sources. It must be same amplitude. Because if different amplitude, you cannot have destructive interference. Because if you different amplitude, one big, one small, how to total cancel each other? If you want to totally cancel each other amplitude, you must have both of the wave must have almost the same amplitude. Okay, almost the same amplitude. That's it. Okay, same amplitude, and then very small distance between the two coherent sources. These two sources these two sources must be very close to each other, even smaller than the wavelength of light itself. Must be smaller than the wavelength. Okay, that means these two sources, these two slits cannot be far away. It cannot be the distance between these two cannot be 1 meter away. Cannot happen. If 1 meter away, no interference pattern happen. It must be even almost smaller or equal to the wavelength. That means even smaller than the wavelength of the wave. Yeah, this is the wavelength. This wavelength can be in nanometer, can be, let's say 400 nanometer. How small is nanometer? It is around 400 exponent negative 9 meter. That is how small the separation between the slit. That's how small the separation between the slit. The two slits must be very, very close to each other, almost undetectable the distance between them. Yeah, the two slits must be very, very small in order to produce this interference pattern. Okay, it's not 1 meter away, cannot happen. Yeah, so now, okay, there's a thing. And then what is mean by coherent source? Coherent source means it must have a constant phase difference. Okay, it must have a constant phase difference. That means these two sources must be okay. I will explain more about phase difference, because you need to learn about the path length. Yeah, you need to learn about the path difference before you can know what is a phase difference. Okay. The thing is, you just have to remember these two sources must have constant phase difference. It can be related to which is my following slide is very beautiful. I just don't have the time to show you, but this is the phase difference lah. Yeah, this is what we call the delta phi or delta L. This is path difference. This is phase difference. So this is what I mean by constant phase difference. You cannot understand now because I haven't shown you example. Phase difference means the delta phi, or it is actually this is called phase difference, or delta L is called the path difference. Path difference. Phase difference is measured in terms of radian. This one is measured in terms of radian. Path difference is measured in terms of meter length. Okay, length. Because phase difference is actually angle. It's about angle. It's about angle. Path difference is about length. But these two are equivalent to each other. Yeah, we can say these two they are almost they are equivalent to each other. So these two waves must have constant phase difference, which we will learn later about delta phi and delta L, and they must have same wavelength. What is mean by same wavelength? Or monochromatic, we say. Monochromatic means it must have these two light must be, what I can say, same kind of light. Like both of them are red light. Both of them I can say if that means monochromatic, that means one color. Let's say I'm using red light. Red light is 700 nanometer. 700 nanometer, only one wavelength. This is actually the wavelength of red light. Okay, that means both of these must use red light. Do I have a red color here? That means both of these must use red light. You cannot. Both of these must be coherent. Means coherent means they have the same wavelength. They have the same wavelength means they have the same color. Same type of light. You cannot use one use red, one use let's say one use green. One use green. How to where is the green color? Cannot say this one cannot this one cannot produce. This one cannot produce what they say, cannot produce interference pattern. These two are not coherent. Okay, not coherent. They must be the same type of light. Both must use red light. Sorry, not this one. Should use the highlighter. Yeah. Both must be the same color. This one is coherent. This one is coherent. Okay, or you can also use both of them. Maybe violet light, violet. Okay, violet. Both use violet. Violet. If violet, violet is actually 400 nanometer. Violet light. Okay, violet. Okay, so they must be we can say same wavelength, only one wavelength. One wavelength is allowed. Only we can say one wavelength of value allowed. Both of them must be same color in order to produce the interference pattern. Okay, okay. So exam always ask you how to produce interference. What condition need to be met? Must have two source. One source cannot. Must have two source. And then these sources must be coherent, and then must have same amplitude, very small distance, almost equal to lambda, between these two sources. And then what is meant by coherent source? Coherent means they are the same color. Only one wavelength. Both must use the same color, and constant phase difference or constant path difference. Okay, that's the meaning. Okay, now constructive interference. Who doesn't know? Everybody knows about constructive and destructive interference. Okay. Okay, I think times is almost up. But if you got other things to do, you can leave first. But if you don't have other things to do, you can continue watching. Okay, continue watching because I'm going to continue this lesson. So if you don't have other things to do, you can continue watching until the end. Okay. If you have other things to do, you can stop watching, go for your other classes, and then watch again these recorded videos in the YouTube live. Okay. Because this video you still can watch again. Don't be afraid. Okay. I'm going to teach slow here. I'm going to go slow over here. All right, so you can do your things. After that, you can come back. You watch again these recorded videos. Yeah, because this YouTube live, everything is recorded. Okay, you don't miss a thing. Okay, all right. Thank you. So I'm going to continue my lessons. Okay, so let me go from here. Now, constructive interference. Constructive interference means it is reinforcement. We know that they constructive. We always say constructive words to reinforce people, right? We don't say destructive words to destroy their spirit or what. They just cancel their spirit. That's what I mean by constructive and destructive. So you see, these two waves, we can say they have the same. We can say same direction. They have the same direction. This one go up, this one also go up. Of course, they construct each other. A plus A become 2A. Understand? This one is A plus A become 2A. So the result, the crest and trough reinforce each other. You see, reinforce each other. I don't like purple. I like yellow. Okay, they reinforce each other, so they become 2A. But destructive interference means, you see, this one have different direction. One go up, one go down. Actually, I write like this. This one is positive A. This one also positive A. That's why positive A become 2A. Become positive 2A. Yeah. Now this one is a positive 2A. Now this one is a positive A, and this one is negative A. So what happened if positive A and negative A become 0, isn't it? Become 0. That's why here amplitude is 0. They cancel each other. All right. They cancel each other. That's it. Now, okay. Let's continue our lesson. Okay. This constructive interference will result in bright fringe. They produce bright fringe. In other words, for bright fringe, we call it maximum. Or sometimes we call it maxima. Maxima is for plural. Maximum is singular terms. Maxima is plural. Or just max. Or just max is it? Or just max. Yeah. Bright, destructive interference, total cancel each other, means dark fringe, or minimum, or sometimes we call it minima, or sometimes we call it minima. Minima is plural, yeah, or just call min. That's it. Yeah, min. Now you see, okay, why here talks about amplitude? Yeah, why here talks about amplitude? So what conclusion can you make out of this amplitude? What is actually mean by this amplitude? Why amplitude affect the bright fringe or dark fringe? Why when we have maximum amplitude, you have bright fringe? Why we have zero amplitude, you have dark fringe? Have you asked about this before to yourself? This one relates back to our semester one, talking about intensity. Still remember? Intensity of light. What intensity? Intensity actually is power over area, isn't it? Power over area, power over A. This A is not amplitude. This A is area. Okay, A is area. The power itself relate back to the energy. Remember in semester one, I think you need to open back your mechanical wave. Your chapter mechanical wave. You learn about this is the power, isn't it? Power, intensity of light. Intensity of light is power over area. Power over area. Power is energy over time. Energy over time. So remember, and energy over time. Energy. What is energy? Energy of light. Energy of the wave is total energy of wave is half m omega square A square. What is this A? What is this A? What is this A? This A is called the amplitude of waves. Remember, half m omega square A square. This is in your mechanical wave. You learned about mechanical wave before, isn't it? Mechanical wave. So what I can say, what conclusion can you make out of this? Intensity of light is proportional to power. Yeah, intensity of light is proportional to power, and power is actually like energy over time. Power is proportional to energy. Energy is proportional to amplitude. This one. You see that? So what can I say is intensity is proportional to the amplitude. Intensity is what I can say. Intensity is proportional to the amplitude square. Okay. Intensity is proportional to the amplitude square. So that means this is I should I should write as the words intensity instead of I can be mistaken as current. That means what can I say from here is the bigger the amplitude, the higher the intensity of light. Remember, wave. Remember your mechanical wave. The bigger the amplitude, the bigger the intensity of light. So that's why this one have the maximum amplitude. You see 2A. This is the amplitude. This is the amplitude. You see, this one has the maximum amplitude. Maximum amplitude. That's why it has the maximum intensity. Okay. So we can say amplitude is like intensity lah. I can say the amplitude is just for like intensity. Amplitude is for intensity. Okay, amplitude is for intensity. This one amplitude zero. Amplitude zero. That means the intensity of light is zero. Amplitude of light is zero. That means the intensity. Intensity also zero. Okay. So amplitude maximum, intensity maximum. Okay. So intensity is proportional to amplitude. The bigger the amplitude, the bigger the intensity. So this one has the maximum amplitude, means has maximum intensity. This that's why bright fringe it forms. This one has zero amplitude after cancel. That's why it has zero intensity of light, become dark, no light. We can say zero intensity means when zero intensity of light means no more light. No more light. It's dark. It's dark. It's dark. Yeah, it form a dark fringe. Okay, like this one, like this one, you can see this one has the that's why they form like here. This one is the bright fringe. This one and this one is the dark fringe. Okay, this one has the maximum amplitude. This one has zero amplitude. Yeah, that's right. Okay, now let's talk about this path difference. What is actually path difference? All right. Who is Waterlooing? Yeah, I don't know who is Waterlooing. I'm so sorry. Yeah. Okay, let's talk about this one. Yeah. Path difference. Path difference. Okay. This is very important. Now, to form an interference pattern, first of all, you must have two coherent wave. Two coherent wave. You see, this wavelength is almost the same, isn't it? Both are green light. You see, green light. You see the wave. You see the wavelength. You see the wavelength from peak to peak. Wave lambda 1 and lambda 2. They are the same. They must have the same wavelength. Then they are coherent. They are coherent. Okay. Now, besides that, and this one. Okay. And also you can see this distance. This distance is very almost the same. Is almost the same as the lambda, isn't it? Almost the same as the lambda. Very small. You see, this one is almost the same as 1 lambda. The separation. Very. This one the separation must be very small. And then they have the same amplitude, isn't it? They have the same amplitude. They have the same amplitude. That's why they must have the same amplitude. That's why they can form interference pattern. Understand? Okay. They have the same amplitude also. Same amplitude. Now, okay. That's not our concerns here. Yeah. Our concern here is about the path difference. Yeah. About the path difference. So you see, at this point P, it receive wave from source 1 and also wave from source 2. Okay. It receive a wave from these two sources. So, which one travel a longer distance? Which source the wave had to travel a longer distance? Of course, the source 2. You have to travel a longer distance. Yeah. P is nearer to the source 1, but further away from source 2. So source 2 need to travel a longer distance compared to source 1. Source 1 easier. Source 2 travel longer distance. Longer by how much? Longer by how much? Yeah, this is the one. Longer by this amount. Because this line, how to get this line? We just draw a 90-degree line. Yeah, we just draw 90-degree line, and we can say I like to use color. Color helps me a lot. This you see, this length and length from here, they are equal. They are equal. Here, this length and this length here are equal, isn't it? I mean the pink color one. The pink color have equal length. This is the extra length. This is the extra path. Extra path or extra distance. Yeah. Extra length. Just length lah. Just extra length lah. Okay. So this is the thing. This path difference is the one that determines whether it form bright fringe or dark fringe. It is this delta L. We call it delta L. That determines whether it form bright fringe or dark fringe. You don't understand? Then never mind. After that, I will explain more in detail about delta L, how it leads to form different fringes as you're going up the screen. You form bright fringe, dark fringe. Because of this delta L. That's it. This is the most important thing in this chapter. I can say this is the most important thing in this chapter. Okay. So how to get this delta L? Very simple. Just take the long minus the short lah. Which one is longer? Which one is longer? S2P. S2P is longer distance minus the S1P. Minus the S1P. Then you get the path difference already, isn't it? Yeah, the long distance minus the short distance. That is the path difference. Understand or not? Okay. That's how you get the delta L path difference. The long minus the short. This is the extra distance. This one extra by how much? This one, it seems that this extra by one wavelength. By one wavelength. This is one example only. This is just example only. This delta L can differ by maybe can differ by 1 lambda, can be differ by 2 lambda, or can be differ by 1/2 lambda or 2/2 lambda. This is what it makes all the bright fringe, dark fringe, everything. Later I will say about this. Yeah. So this difference, as you're going up higher to the screen, this path difference will be different, because we can say S2 have to travel even longer if you're going up the screen. Yeah, have to travel even longer compared to S1. Yeah. So okay. This delta L 1 lambda is just one example. There are many other examples. Can be 2 lambda, 3 lambda, 4 lambda, 1/2 lambda, 2/2 lambda, and so on. Okay, now let's move on to next slide. Yeah, next slide. Okay, this one. Okay, next one. Okay, now I have these two in-phase sources. Two in-phase sources. Okay. Now I have two in-phase sources. Two in-phase source means what? Means each of them is the same direction. You see that? They have the same direction. Like in-phase means what I can say is like this lah. In-phase means one wave is like this, another wave is like this. Means they all go to the same direction. It start off with the same direction, positive A, positive A. This is called in-phase. Understand or not? This is in-phase. They start off. Is in-phase. It start with the starting point. The starting point is going in the same direction. This is called in-phase. Antiphase. What is mean by antiphase? Two antiphase source. That means one wave is going. One wave is going up, another wave is going down. This is antiphase. Understand? That means one going up, positive A, another one is going down, negative A. At the starting point, these are antiphase. These are antiphase. Okay? I will touch these two examples now. Okay? I will start off with the in-phase first. Yeah? In-phase. That means they start off with the same direction. Yeah, going up, going up. Okay, you look at these two slits. These two are in-phase source because both of them are going up, isn't it? Go up, go up. Yeah, they have initially they have a positive A. This one also positive A. Even though both going down also called in-phase. Both if going down also called in-phase. You like this. Like this, both also this negative A, this negative A. This one also called in-phase. Understand? Because they have the same direction. This is also called in-phase. Okay. Now you see this one. This one go up. This one go up. So both they are in-phase lah. Both in-phase. So at the center it form center bright fringe. You see what's the result? When they meet at the center. At the mid and center, you see these two light, they have the same distance. I can say the path, they have no path, they have the same length, isn't it? They have the same length. They have the same length. So of course, in the end, they sure in phase also. In the end, also in phase. Both go down. So when they have the same direction, they have constructive interference. That's why it forms bright fringe. You see that? But you see, like for antiphase, antiphase means like this one lah. This one go up, positive A, and this one go down, negative A. In the end, also antiphase produce dark fringe. Okay. Before I go into here, I think I need to let you know about this path difference first. In depth deeper. Okay. You see, like this. I give one example. Very, very simple example. I give you one very, very simple example. You see this one. I have two waves. I have this wave one. Okay. This is wave one. This is a wave two. Okay. Wave two I put as I should have put as green color lah. Wave two green color. And no, I shouldn't start with this one first. I should start with two in phase source. Yeah, two in phase source. Understand? I start with two in phase source. Okay. I want to talk about these two waves. Yeah, I want to talk about these two waves. Now, these two are in phase source. I can say they are in phase because positive A and this one also positive A. They are in phase. They are in phase. Yeah, they are in phase source. Now, I want to group them first. I want to group them. Can I group them? Yes, I can group them. It's like this so much. Okay. Now, if let's say these two wave, I should group this also. I should group this also. Group them. Group. I like this. Okay. Now, these two start off with the same point. They start off with the same point. Yeah, they start off with the same point. So we can say, do they have any path difference? Do they have any path difference? No. The delta L, I can say is the delta L is 0. Delta L is 0, isn't it? So that means in the end, they form what? They form what? They also constructive interference. They form bright fringe, isn't it? They form bright fringe. Okay. Now, I want to show you. I just want to show you this. I think I will do until here. Yeah, about path difference first before I go to Young double slit. Okay. Okay. So this one, these two has no path difference. No path difference. So we can say in the end they interfere with each other. Here it surely form bright fringe. These two, because these two in the end they are also in phase. They are also in phase. They constructive interference. Okay. Now, I want to talk. I'll give you another example. I give you another example. Here, this one. This one. Yeah. I want to talk to you. Yeah. This one. Okay. Now. Okay. Let's take this second wave. This second wave. Go a little bit here. A little bit here. Okay. A little bit here. So what can you say? I should take I think I should adjust over here. Okay. Which one has a longer distance? Which one has a longer distance? Yeah. Which one has a longer distance? See that? The path difference? I don't like the thickness. Okay. So just hold on a second. I rub off everything. Sorry. Yeah. Okay. Never mind. Okay. So now let's say over here. Which one has a longer distance? What's the path difference between these two? What's the path difference between these two? The path difference is this part, isn't it? See this part, which is this one. This is the path difference. This one has a longer distance. Don't say we only stop until here. Yeah, we only stop until here. Okay, this one don't see anymore. Okay, which one has a longer distance? The wave one has a longer distance. What's the difference between these two lengths? Half lambda, isn't it? So the delta L for this one, The delta L for this one is half lambda. Half lambda. So what happened is, what happened if half lambda? You see what happened next? They become antiphase already. Do you see that? They still, these two are still in phase source. These two are still in phase source because they start off with the same direction. You see that? Go up, go up. These two are still in phase source, but they end up with what? I should drop this off. Okay. This part can be cancelled off. Okay. They end up with what? They end up with opposite direction. This one go down, this one go up. This one extra length of half lambda. But in the end, they become antiphase. They produce what? They produce dark fringe. Do you see that? Okay, now I give you another example. Okay, I give you another example. This one for later on. Yeah. Now I give you another example over here. Okay, this one. Yeah, over here. Okay. Now I want to talk to you to this one. Okay. I don't want this. Just drop this off. Okay. All right. Now, let's say that I drag this one further down. I drag this further down to here. To here. Okay. Now, start off with here. Start off with here. The difference between the two lengths is this part. So until which part? Until here lah. Until here only. Yeah. Until here. Don't bother about here. Okay. So now, what's the path difference? Come on, guys. What's the path difference? What is the path difference? What is the path difference? You see, 1 lambda, isn't it? 1 lambda. They are still in phase source. They are still in phase source because we can say it's start. They start with in phase. They start in phase source. They start in phase. So in the end, what happened? In the end, what happened? Ayo, this one go down, this one also go down. It go down. This one negative A. So at the this is what we call, this is at the screen. This is what we call the screen. The screen here. The screen here, it form what? Yeah, all this. what I'm talking now is all these happen on the screen. You know, this is the screen. This is the screen. This is all the screen here. This is the source. This is a source. This is a source. I can say this is the source lah. This is the source. The source start with in phase source. Start with in phase source. So at the screen, what happened? So you see, go back to this one. So you see this one. The path difference is path difference. The delta L is 1 lambda. The path difference delta L is 1 lambda. So so in the end, it form what fringe? What fringe? It form constructive interference because same direction. Bright fringe it form. It form a bright fringe over here. It form a bright fringe. That means here at the screen here you can see bright fringe. This one just now also at the screen here you can see bright fringe. But this one, just now this one, opposite direction they form dark fringe. They form dark fringe. Understand? This is what it means. This is what. Okay, I give you one more example. I like this too much. I like this too much. Okay, I give you one more example. Yeah, I like it. Yeah. So okay, let's take it. Let's say this one. I need to wrap off this one. This I need to wrap off. Okay, I need to just take here. This one go this direct over here. Maybe go over. Which direction should I go? Wait. Let me see. Just now is a 1 lambda. Now is a let's say 1 half lambda. Now let's say 1 half lambda. Like this. So that means I end until here. Let's say I end until here. Okay, don't bother about this part. Okay, now let's go on to this one. Do you see that? I like this so much. So, okay, what is this? What is this? What is this? Okay, so what can you say about the source are in phase? The source, they are in phase because they start off with the same direction. They are in phase source. But what happened at the screen? What happened at the screen? So what's the path difference? What's the path difference? Delta L, what's the path difference? This is 1 lambda. Until here is 1 lambda, another half. 1 lambda plus another half. So this is 1 plus half lambda. This is 1/2 lambda. Never mind lah. I just write as 1/2 lah. 1/2 lambda. 1/2 lambda. So 1/2 lambda. What do you get? What do you get on the screen? Come on, man or girls. Come on. What do you get on the screen? You get opposite. Yeah, antiphase. Become antiphase already. So they get a dark fringe. You get a dark fringe. They interfere with each other and they form dark fringe. They form dark fringe. They form dark fringe. And they form dark fringe. Okay. Now, what conclusion can you make out of all this? What conclusion can you make out of all this? You see, when it is, I clarify here, when it is 0 lambda, when it is 0 lambda, 1 lambda, or 2 lambda, later on you have delta L 2 lambda, or you have delta L 3 lambda, so on, which is delta L equal to m lambda. These all will form bright fringe. You understand? These all will form bright fringe. But if it is we have half lambda, this actually is like 0 plus half lambda. Okay, this one is like 1 plus half lambda. As long as you have half lambda, later on you have 2 plus half lambda, and you have later on you have 3 plus half lambda. Okay, so the rest, delta L, when it is m plus half lambda, what did it form? As long as you have that half, you have that half lambda, it will form dark fringe. For in phase, this is only for in phase source or start. It start with in phase. It start with in phase doesn't mean it end with in phase. You understand or not? It start with in phase, it can end with antiphase. This one is only the source is in phase. The source is in phase. It start with the in phase. What I say is both go up, 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 go up. They all start with in phase. Okay, but they end with different result. Yeah, based on the path difference, based on the delta L, based on the delta L lah. Based on the, we can say what is this delta L? This delta L is called the path difference. Path difference. Okay. Now, I already finished. In phase, for in phase source, when the delta L equal to m lambda, multiples of lambda, it form bright fringe. When delta L equal to m plus half lambda, it produce dark fringe. Okay, I finished about in phase source. How about antiphase source? I have to redraw this all over again. Antiphase, I think you can guess, but never mind. I can show one example. Antiphase is that means it start off with a different direction. Okay, I need to copy this. Okay, I need to copy this, and then I need to draw. Where should I paste? I should paste over here. Paste over here. Okay, now let's look at this one. Let's look at this one. Okay, let's look at this one. This is now I'm talking about what? I'm talking about antiphase. I'm talking about antiphase already. I'm talking about antiphase, antiphase source. Why the color change? I don't like. I like green. Okay. Now, I want to talk about antiphase source. Okay. Antiphase source. That means it start. Source means it start. Doesn't mean it ends with antiphase. Understand not? Only the starting point is antiphase. But they can end with in phase. Okay? Remember that. Now, okay. Now, these two waves are antiphase because they start with opposite direction. Okay? I draw. Why like that? So this is considered wave 1. This is considered, the other is considered wave 2. So this, the source is antiphase. The source is antiphase. And I can say antiphase source. The source is antiphase. Okay. So now, what's the result? What's the result? Start from here. Okay, come on. Like this. This is the screen. This is the screen. What happened at the screen? What can you see on the screen? What can you see on the screen? At first, what is the path? First of all, what is the path difference? What is the path difference? What is the path difference? What's the difference in their length? No difference, isn't it? Same length, isn't it? Delta L is equal to 0 lambda, kan? 0 lambda. 0 lambda. 0 lambda, 0 lambda. Yeah, 0 lambda. So what it ends with what? This one become negative A, this one become positive A. So what happened? It formed dark fringe. It formed dark fringe because they are antiphase in the end. At start antiphase, at last also antiphase. Here also antiphase. Here at antiphase. So dark fringe lah. Dark fringe. It formed dark fringe. It formed dark fringe. Okay. So now, I need to. Okay. Now, let's go on half lambda. Let's go on half lambda. Okay. I should actually okay. Let's go on half lambda. Let's put over here. Let's go on over here. All right. Half lambda. What happened to the half lambda? I need to rub off everything of this one. Okay, everything. I need to rub this everything lah. Never mind. I can write again. So I should actually group. Okay. Never mind. Just okay. 1 second. Yeah. Sorry. And sorry. Yeah. I'm so sorry for your time wasted. Yeah. Okay. Now, wave two. Maybe I should group this thing first. Group this thing so it's easy. Okay, never mind. Okay, I know how. Yeah, I need to group this first, easier so that easier for. Never mind. Okay, impossible. Okay, so come on, never mind. I need to group this first, easier for me to handle things. Sorry for your time. Yeah. Okay, I grouped this already. Nice. Now, I move this wave a little bit further away, which is half lambda away. Yeah, half lambda away. So what can you see from here? What can you see from here? So what's the difference between the path difference? What's the path difference? Only n until here, yeah. Only n until here. So this one don't need to see, yeah. So what's the path difference? Tell me, what's the path difference? Okay, what's the path difference? This is the path difference. This one, you see that? This is the path difference. So what's the path difference here? What's the path difference here? What's the delta L? What's the delta L? Come on. Half lambda. That's right. Half lambda. Half lambda. So what fringe it produce? They go in the same direction. Negative A, isn't it? It go in the same direction. Negative A. So what does it mean? When you go in the same direction, what does it mean? That means they are constructive interference. They produce bright fringe. What I can say is produce a bright fringe here. I produce a bright fringe because in the end, even though it is an antiphase source, but it ends with in phase, and antiphase source, but in phase and end with in phase. So it produced bright fringe. You see that? Difference by half lambda. Now, okay. So you can see the pattern already. I don't need to draw everything, right? You can see the pattern already. So later on, if I move on another one wavelength, yeah, and move another half lambda, it become what? It become what I can say. You can see the pattern already. So from here you can see if 0 lambda, 1 lambda, 2 lambda, 3 lambda, multiples of lambda, delta L equal to m lambda, all will produce bright fringe. But for this one, as long as you have half lambda, the next it should be 1/2 lambda, and then you have 2/2 lambda, as long as you have that half lambda, 3/2 lambda, and so on. Or we can write as delta L equal to we can say m plus half. Anyway, I haven't tell you about what is m. I haven't tell you about this m. Okay, so this one is produced dark fringe. Okay, what is m? M is called the order. M is called the order. M is called the order. Order of fringe. Order of fringe. This order, you see, this order start from what value? This order start from what value? 0, 1, 2, 3. M is 0, 1, 2, 3, and so on. Same to this one. This one also 0 plus half, 1 plus half, 2 plus half, 3 plus half. So it's also start from 0, 1, 2, 3. The top here also the same. Yeah, the order start from 0. Okay. So this one produce. This is called the antiphase. Do you see that? This is the antiphase. This is what happened to the antiphase. So what conclusion can you make out of all this? Yeah, out of all this. Do you see that? Do you see what happened? For in-phase source, when delta L is equal to m lambda, it produces bright fringe. But for antiphase source, it is inverted. Yeah, it become opposite. The m lambda. Wait. I'm mistaken. Sorry. I mistaken everything. Yeah, I'm so sorry. I mistaken everything. This one just now should be. I mistaken everything. Yeah, I'm so sorry. This one should be delta. Then delta L equal to. Yeah, I'm correct. I'm so sorry. No, m lambda. No, this one is the mistake. I wrongly write. Yeah, wrongly write. Yeah, this one. This. Okay. Just now what I can say is here, as long as you have multiples of lambda, m lambda, it will produce dark fringe, isn't it? It produce dark fringe. But for this one, it produce bright fringe. This one it produce bright fringe. Okay, so what can you say from here? What's the conclusion can you make from out of all this? For in-phase source, if you want to produce a bright fringe, the delta L must be m lambda. But for antiphase source, the m lambda goes to dark. The m lambda become what? The m lambda become dark fringe. The m lambda become dark fringe. You see that? So the bright fringe become this one. Yeah. Okay. That means for in-phase source, the m lambda is producing bright fringe, but for antiphase source, the m lambda become dark fringe. You see that? For bright fringe, you need to become m plus half lambda. Become the bright fringe is over here. You see that? Using m plus half lambda. But for in phase, for the dark fringe in phase source, it is the for dark fringe in phase source, dark fringe is using m plus half lambda. But for the dark fringe, for antiphase source, the dark fringe is using m lambda. Okay, so that's the difference. Yeah, maybe it's a little bit too bright. I need to make the okay, hang ready. Okay, should this one, yeah. So this is the one, okay, a dark fringe, yeah. This is where the dark fringe. You see the difference? In phase for bright fringe is using m lambda, but for dark fringe is using m plus half lambda. But for antiphase source, the bright fringe is using m plus half lambda, but for the dark fringe is using m lambda. That's the difference. Okay, so that's our lesson until today. Until here, later on, we'll continue with young double slit. Okay, thank you for your time. See you again. Bye.